energy of a photon of characteristic X-ray in Coolidge tube comes from. So as I explained in the previous question, what happens when electron, highly energetic electron, strikes the target, then what happens? The two processes are there. The first process is that kinetic energy of the electron reduces, and the second process, the striking electron knocks out the electron of some orbit. Okay, so first one gives rise to continuous X-ray, and the second process gives rise to the characteristic X-ray. Suppose electron, highly energetic electron, removes one electron from the K shell of the target material. So we know that in a K shell, according to the Pauli's exclusion principle, two electrons may reside, but here one electron is being knocked out. So there is one vacancy. So what will happen? It may happen that the electron from the higher energy level will jump into this shell, and that particular transition gives rise to characteristic X-ray. For example, K alpha X-ray is corresponding to the transition between L to K, and similarly the K beta X-ray corresponds to the transition between M to K. Okay, because K alpha, K beta, and similarly K gamma also can be defined. So we have understood by now that energy of the photons of characteristic X-ray in the Coolidge tube comes from the atomic transition in the target. Means when electrons are transited from higher energy level to the lower energy level, where vacancy is created by these highly moving electrons which are used to produce the X-rays. So to fill that vacancy, higher energy orbit electrons are basically shifted to this level, so difference amount of energy is lost. So that energy corresponds to the energy of the photon of the characteristic X-ray. So atomic transition is responsible for this.